basic rules. When you're looking at division with exponents, when we originally looked at multiplying exponents, we saw that x to the fifth times x to the third, you are adding your exponents to get x to the eighth. In this case, again, dividing being the opposite. If here we're adding, then here, yes, we want to subtract and get an x squared here, okay? And then if you're looking again, let's say we put the 3 on the top and the 5 on the bottom, and we subtract. Now again, you're subtracting the exponent from the numerator by the exponent from the denominator. And then in this case, you actually end up with a negative exponent again. And again, the understanding, multiplicative inverse. So we're not saying how many times x is being multiplied, we're saying how many times it's being divided. How many times it's being divided.
So, Mr. Devin,
Yes.
You said subtracting on what?
Say again?
Subtract on what?
When we're dividing.
Okay, just check.
Dividing variables with exponents. In this case here, we're multiplying with exponents, so that's where we're adding exponents. Here is different, we're subtracting exponents. Now, if you look at this, okay, the understanding too is that, okay, you have variables with exponents. A trick or something you could always look at, let's say you have maybe bigger numbers, or you could just evaluate this and say to yourself, okay, I know 12 minus 20 is going to be negative 8. And then I take the negative 8 I put on the bottom. Or you could just look at this and say, where is there more of this variable? On the top or bottom? On the bottom. And then you could just say by how much? Well, there's 8. And maybe you can skip looking or subtracting each variable. Now you'll get an example. 3 different variables, each of which you're dividing. And the idea being, you can only, basically the same thing before, you can only work with similar base variables where the bases are the same. Same thing here. We're evaluating this like E5 minus 1, because we're looking at the E separately, from the F separately, from the G. And you're looking at E5 minus 1, F 8 minus 3, G 1 minus 4. Again, subtracting the denominator from the numerator. So the numerator being 5 minus 1. Now I left the E without a variable here so you guys could see a case in which you don't have the variable and we assume that it's a 1. We're assuming that's going to be a 1. Okay, so if you see a variable, or you see a variable without an exponent, assume it's to the first power. And then you have e to the 4th, f to the 5th, g to the negative 3. And then this exponent to the negative power, we're saying this is a dividing variable instead of a multiplying. So that's where we e to the 4th, f5, g to the 3rd on the bottom. Now a shortcut to that would just be, okay, I have 5 e's here, 1 e here, so I have 4 on the top. I have 5 more f's here, and then I have 3 more g's here. Again, I have a variable without an exponent, so I'm going to assume that's a 1, and then I'm just putting g to the 3rd there. When I'm working with these, that's how I'm looking at it. I'm just like, where's there more of each variable, and that's where it's going to go. There are some cases where you have to subtract in order to simplify stuff, and we'll get to that. You can also have an example where you have an actual integer involved. where you're actually going to have to evaluate what's happening with the 40 and the 8. Now this is just a simple reduction. That's all that is. Okay, you're looking at that like if you have your simple fraction, you're reducing 40 over negative 8, which will reduce to negative 5 over 1, yeah. So you can just start with that. And again, 5 minus 1, 4, but I do recognize I have 4 more x's on the top. I can write it as such. And then y, 4 minus 7 would give me y to the negative 3. That's when we would put this to the bottom, but I recognize I have 2 more y's on the bottom. Another example would maybe be a question in which you would end up with the integer on the bottom. I also threw in an interesting case here. Okay, here we know 5 over 15 is going to reduce to 1/3. Let me draw a nice line here so I can make some room for some variables. But you notice here, you have x to the 6 on the top and x to the 6 on the bottom. 6 minus 6 is 0. Any variable raised to the 0 power is just 1. That's called a multiplication identity. Basically saying this is the product of 0 numbers. So any number times itself just gives you a 1. So the x's are gone. And you'll see this as you go on to pre-calc and whatnot, that you'll be doing simplifying variables and canceling. And then again, 2 more y's on the bottom, 3 more z's on the top. There's my final answer. I can write this without the 1. You may see it like this, z to the 3rd, 3y squared. You may see that. I know you asked about that 1 being there and not